on the directions, but the directions say write P of X as your quotient times your divisor plus your remainder. Okay? So we try to do that. Try to find all those things. And there's a couple different ways you can do this. The first way we talked about earlier in the week was to use long division. So I'm going to put 7x cubed minus 8x squared minus 7x plus 0 in my as my dividend. Okay. Now make sure that you put that 0, even though it's at the end, it is still a placeholder, and it's going to be useful for you to recognize how to line things up correctly with that placeholder. Okay. So make sure we're doing that, even if it's just a constant. The next thing is to put your divisor out front. So 7x minus 8 goes out here. And now if you remember, the thing we did was we sat and we tried to think about what can I multiply by 7x to get this 7x cubed. So what would that be? X squared. So put x squared up top, and I'll multiply. And now when I multiply, x squared times 7x gives me 7x cubed. And x squared times negative 8 gives me negative 8x squared. Okay. I always multiply by a negative, so I change all these signs and add straight down. So those are going to go away. And this is just kind of a unique situation where those go away as well, right? Okay. So all that stuff went away, but now we still have this remainder. Okay, for that first product of x and 7x minus 8. So you need to bring that stuff down. All right, so negative 7x plus 0 needs brought down. And now I think, what do I multiply 7x by to get negative 7x? Negative 1. And now I'll multiply that through, and I get negative 7x plus 8. That's why I put that 0 in there. I think sometimes people will not know to do that plus 8 because it doesn't go under anything if I don't have that 0 there. It becomes very important when we do this through synthetic division. I'm going to change signs and add straight down, so it gives me a remainder of negative 8. Now, I know to stop there because this had an exponent of 1, right? A degree of 1. And this one here has a degree of 0. So once the degree is lesser in my remainder than it is as my divisor, I stop. Okay? What is x to the 0? 1. So that's what we have here, negative 8 times 1. So that's my remainder. So what I always do is, okay, when we get done with this stuff, I know the top up here was my quotient, q of x. I know this was my divisor, d of x. And I know this is my remainder, r of x. And if I can identify those things, isn't it simply just kind of plugging into this thing here? Q of x, x squared minus 1. D of x, 7x minus 8. R of x, negative 8. And that gives me exactly the same thing as what they're showing the answer to be. One thing you should know and recognize, though, is the reason this works, the reason we're able to say that those two things are the same. If I were to FOIL that out, FOIL those two binomials out, and then once I get that result, subtract 8 from it, I will get back to 7x cubed minus 8x squared minus 7x. Okay? It's the same logic as if I were to take, I don't know, 15 and divide it by 4. Goes in 3 times, right? 3 times 4 is 12. I have a remainder of 3, correct? So then my remainder, so I go 15. 15 should equal my quotient times my divisor plus my remainder. Would that make sense? 3 times 4 plus 3, is that still 15? Yeah, okay. So same thing happens with polynomials. And a way to think about that is that this is exactly the same kind of idea as what we've got here. Because when I know what x is, are these just numbers? Concrete values that you divided? Yeah. We just don't necessarily know what x is. So that's one way of doing it. Okay. Now the other way of doing it is using synthetic division. Now I like synthetic division because it's a little bit quicker, but I want to talk about the answer that you get here and how maybe it doesn't match identically to what we just did. Okay, but it is still a truthful answer. When I do synthetic division, again, we're going to go put our coefficients, 7, -8, -7, and 0. This is extremely important that you put that 0. With long division, if the constant is a 0, I think you could probably neglect it and still be okay. I do think, though, it is a good practice to put it in there. But with synthetic division, if you don't put it in there, you're going to miss what you think your remainder is. Okay, and we'll talk about that when we get to that point. All right, now what goes in this box? You have to do a little bit of work here to figure out what goes in that box. Because we always put the what we think might be the 0, right? Okay, so this thing here is going to provide what we might think as being the 0. Okay, so I got to take 7x minus 8, set that equal to 0. X will equal 8/7. Does that make sense, everyone? So 8/7 is what goes in that box. Okay. Now, generally speaking, when that becomes a fraction, some of this stuff gets pretty ugly. But if you look at the numbers that are in as my coefficients, they're 7 and they're 8. So this thing is probably becoming pretty easy to actually multiply because of how we're multiplying by that denominator of 8/7, and things will cancel out. It's real nice. So take my 7 down. 8/7 times 7. Okay. This denominator is 7, and that numerator is 7. They're going to cancel out, right? Leaving me just 8. So 8 goes there. Add straight down. I get 0. Well, that's nice again. Multiply gives me 0 there. Add straight down gives me -7. Well, that's nice again because the 7s cancel out. It only gives me -8. And my remainder down here is -8 then, right? If I didn't have that 0 there, just think about what would have happened. If I didn't have that 0 there as that placeholder, I would probably think I'm done right there, wouldn't I? Okay, so you need to make sure you have that placeholder as a constant for this procedure. Okay, so that's your remainder. So this is your remainder, R of x. This is essentially your quotient, Q of x, and this was your divisor, D of x. Okay, now the divisor was x minus that, right? This was x to the third. So what's this become? X squared. So when I write my P of x is equal to the quotient times the divisor plus the remainder, that's going to look like 7x squared minus 7 times x minus 8/7 plus -8. Let's put minus 8. That is P of x. Now, does that look exactly like the way we did it up here? They're different, right? The linear factor is a little bit different. The quadratic factor is a little bit different, right? But think about this. Take this 7. This has a factor of 7 in it, right? Okay, think about how these things are the same. If it has a factor of 7, you could essentially rewrite this as 7, x squared minus 1, x minus 8/7 minus 8, right? Now you've got 3 numbers being multiplied together there, right? Does the order matter on how you multiply? No. So can I take this 7 and actually distribute to this stuff here? And if I did that, now is that the exact same thing that we had up there? 7x minus 8 times x squared minus 1. 7x minus 8 times x squared minus 1. And what? Minus 8 minus 8. So they are the same. Does that make sense to everybody? WebAssign is not going to distinguish whether that was the one they wanted or that was the one they want. Okay? You can type in either one and be fine. Okay? But I know some of you prefer synthetic division over long division. That's the way you would go about doing it. But like I said, sometimes with long division, you're not going to get those fractions to have to deal with. With long division, the process might be a little bit longer. With synthetic division, you might have to multiply fractions. You guys have anything you want to talk about? Any questions on the assignment that you were struggling with, Sean? All right, so this is leading us to the types of questions that we're going to deal with specifically today in our examples that we go over with the rational root theorem. But what we want to do, it says first show that these are zeros. So you want to put in, or run this thing through synthetic division. So I'm going to put 4, -9, -50, -27, and then 10. Make sure that you put placeholders. If your red numbers, if any of them end up being zeros, you would need those placeholders. And then out here, it doesn't matter which one of these you start with. I'm going to start with -2. Actually, let's do this. Let's start with a fourth, because these numbers are pretty big. And I think if I start with a fourth, it's going to reduce them a little bit for us to make things a little bit easier with the 2. Bring my 4 down. What's a fourth of 4? 1. Okay. Add those straight down. I get -8. Now, what's a fourth of 8? 2. So I get -2 there. So I get -52. Okay. What's a fourth of 52? 13. Okay. So it gives me -13. So that's going to give me, what, -40? And now what's a fourth of 40? 10. So -10. And that gives me 0. Okay. So that's proof that 1/4 is a 0. Okay. Now with this type of problem, you're also going to show that -2 is a 0. And you could start, like we did this yesterday, we could start back at the beginning with 4, -9, -15, -27, and 10. But if -2 and 1/4 are both zeros, okay, and I start with 1/4, then -2 should divide the remainder of my polynomial after I divide by 1/4. Does that make sense? Okay. Or vice versa. If you would have started with -2, then 1/4 will end up dividing. If it is a 0, it will end up dividing the remainder that you get from your polynomial when you divide by -2. So I'm never going to, and especially for this problem, they ask you to find the other zeros. You don't want to go back up to the beginning. You want to keep breaking this thing down. So just kind of keeping track of where we are. This was x to the 4th. This was basically x to the 1st minus 1/4, right? We always want to understand that when we divide using synthetic division, this number out here, this divisor is always linear. So you take a whatever power, divide it by a linear power, it depreciates it by 1 degree, right? So it becomes x cubed. Okay. We basically want to keep dividing down with these zeros, or these potential zeros, until we get a quadratic function. So right now we've got a cubic, so we keep going. All right, so I'm just going to put a box out here again and put my other number in it. So -2. Draw my line. Bring my 4 down. Multiply, get -8. Get my -16 here. Multiply those together, I get 32. So it gives me -20. Multiply those together, I get 40. And now there's that 0, right? So that 0 is a proof that -2 is a 0, or I could say that x plus 2 divides p of x. Here would have been x minus 1/4 divides p of x. Okay. So right now what we end up with my division here is that p of x can be written as a product of my linear factors, x minus 1/4, okay, the factor that came from that 0, and then x plus 2, the factor that came from that 0. Okay, so that's your divisors times your quotient, right? Or your divisors times your quotient. Here's your quotient after dividing by those two things. And it's got, now that was x cubed. You divided by a linear term out here, x minus -2, so this becomes x squared, right? So 4x squared minus 16x minus 20. Okay, so that's what we get after we do synthetic division. We depreciate that original polynomial by ultimately a degree of 2. Okay, now that 4x squared minus 16x minus 20 we have some tools to factor that even further. And this is that second part of the question that they're asking for. If I look at just that quadratic, what's the greatest common factor in there? 4. So I'm going to rewrite this as 4x squared minus 4x minus 5. And now how does x squared minus 4x minus 5 factor? X minus 5, x plus 1. And we still got that 4 out there, right? Okay, so I want to know what P of x is. P of x is still going to have these linear factors of x minus 1/4 and x plus 1 or x plus 2. Okay, and I know people are not going to write it that way. They're probably going to take this 4 and place it somewhere. I don't care where you place it. I'm going to put it out front. So 4, x minus 1/4, x plus 2, x minus 5, x plus 1. So that's P of x. That is the original polynomial broken down to all of its linear factors, right? All those exponents are 1. Okay? And what's nice about that is that the question says, what are your remaining zeros? Those remaining zeros came from those two things, right? So my remaining zero is x equals 5 and x equals negative 1. But it's nice to be able to develop that polynomial in the format that we came up with. Now you might also see people do this, and there's nothing wrong with this. Okay? You can take that 4. Okay, because this is a number, that's a number, that's a number, that's a number, that's a number, right? I know what x is. So I've got five numbers being multiplied together. Can I take any 2 of those and multiply them together? So why can't I do this? Why can't I write that 4x minus 4 as just 4x minus 1? Can I do that? So if you want to rewrite this as, there's nothing wrong with it, as 4x minus 1, x plus 2, x minus 5, x plus 1. And that makes the most sense of where to multiply that 4 through if you want to. But you can multiply it through any one of those linear factors if you want to. Or you can just leave it out front. Doesn't matter. Okay? I like to leave it out front. I like to have all my coefficients of my x's to be 1s. Because then it's instant to think about what the zeros are. Does that make sense? If I have a factor of 4x minus 1, I got to do a little bit of work to find the 0, right? Okay? So ultimately up to you on how you do that. But that's how you're going to always approach these things. With this question, everybody should have gotten a 4th degree. Whenever you see one of these questions right now, they'll give you a 4th degree. If they gave you a 5th degree, they'd probably give you 3 C values. If they gave you a 6th degree, they'd give you 4 C values, because they're going to give you enough information to be able to find the zeros to depreciate this function down to a product of a bunch of linear terms. Okay, and then this will be a quadratic, and then you know how to factor quadratics. Okay, because they're trying to build some understanding of how we progress through the next section. Okay, and I want to talk about that a little bit right now. Section.